Hey guys and welcome back. So finally, the 2024 Aiming for Grade 9 papers that are released by Pearson EdXL have finally come out. In the description you're going to find 9 other Grade 9 papers that I've done over the years, but these are predicted papers. So when it says Grade 9 type questions, it means it's going to be the hardest questions of each style of question, if that makes sense. So for example, algebraic fractions, hey, here's what the hardest thing that can look like is. Now, I would like to point out that if you find the first few questions fairly easy, that's because it is designed to be a test paper, so the beginning is going to be easier than the end. But some of the last few questions are actually pretty tricky. So if you're finding the beginning easy, I'd recommend just skipping ahead in the video and looking at some of the other questions to make sure that it all, it's all easy to you. I don't think it will be, because some of the end stuff is pretty interesting. Pretty interesting. You have some interesting style of questions coming up. But I will go through all of it, and I'm going to talk through my thought processes, so that way when you come into the exam and you get those last few questions which are really tricky, you'll know exactly how to approach it. And again, there are 9 other papers that I've already uploaded that I'll put in the description of this one if you want to check those out. But without further ado, let's jump straight into question 1, which is an algebraic fraction question, which honestly isn't too bad. So when you have something like this, it says to solve. But to solve algebraic fractions, you need to first do the addition, subtraction, multiply, or divide that it says here. So here is a subtraction, which means we're going to make the denominators the same. So we're going to times the first fraction, top and bottom, by x plus 1, which gives me x plus 1, over 2x plus 1, minus, times this one by 2, so we have 2 times 2, which is 4, over 2x plus 1. The reason why I know to do that is because there is a subtract in the middle. If there's a subtract or an add, you need to make the denominators the same. If it's a times or divide, you just do normal times or dividing by fractions. If you forget, what I'd recommend is, so for example in this question, I might write something like, okay, how would I do a half minus a quarter? Then when I'm thinking through that, I can use that to then answer this question, because it's the same steps, it's just that we're using algebra instead of numbers. After this, we can actually do the subtraction, so we have x plus 1 minus 4 over, let's just expand that bracket, it's going to be 2x plus 2. I'm going to times this up to this side, and now the equation becomes a lot easier to solve. So again, the goal here is to get a linear or quadratic equation that's fairly easy to solve. So timesing this up is just an equation with a bunch of x's, so expand the brackets, we get x squared plus x minus 4 equals 2x plus 2. I'm going to minus 2x on both sides. So the x squared is not going to change. X minus 2x is of course negative x. Then I'm going to minus 2 from both sides. And we get minus 6 equals 0. So we want two numbers that times to minus 6 and add to minus 1, which means the negative number is going to be bigger. So it's minus 3 and 2. So x minus 3, x plus 2 equals 0. So our answers are x equals 3 and x equals minus 2. Simple as, for 4 marks. So where did you get the marks? You get a mark for making the denominators the same, a mark for timesing them to the other side, so to make a normal quadratic equation, a mark for correct. So when I say correct factorization, you could use completing the square, you could use quadratic formula, that gets you a mark, so just to label it. A mark for combining them or making the denominators the same. A mark for making it a quadratic you can solve. A mark for using a method to solve it, whether it's factorizing, quadratic formula, completing the square, whatever. And then a mark for getting the correct answers. Quite simple, but let's move on to the second question. Okay, I see some algebra, I see some shapes. So that does mean it might be kind of interesting. So we have a solid wax cylinder. It has a height of 9x, a radius of 2x, cool. It's melted down and made into a single sphere of radius r. Find an expression for r in terms of x. Okay, so when I think about melting something down, I'm thinking of its volume, right? Because this lump of wax that we have has a certain volume. When I melt it down and make it into a sphere, it should have the same volume, right? In the same way that if I, for example, I get a sheet of paper, it has a volume, I scrunch it up into a ball, that ball has the same volume as the original sheet of paper because it's the same amount of paper. So, in other words, this question is saying that the volume of the cylinder is equal to the volume of the sphere. You get these equations in your formula booklet, but the volume of a cylinder is simply the area of the front face, so it could be the top or the bottom, doesn't matter, which is pi r squared. So pi times 2x squared multiplied by its length, which is 9x. Again, the volume of a cylinder is the exact same as the volume of a prism. So you're looking at the area of its face, whatever its front face is, times by how long the object is. So that works for literally any shaped prism. So even if you had like a pentagon and you had a prism like this, you'd work out the area of the front, or they give it to you and you'd times it by its length. It's always the same, no matter what shape it is. That should equal the volume of a sphere, which is 4 over 3 pi r cubed. And it says here that the radius is just r, so that's all I'm going to have. And we need to find an expression for r in terms of x. So what does that mean? What it means is I'm going to rearrange for r equals. And that's it. So let's do that. First thing I notice is I can cancel out pi on both sides. I'm going to do this 2x squared, so that becomes 4x squared. One thing to note, and a lot of students get this wrong, is when they do this cylinder where they have pi r squared, they don't put the 2x in brackets. So they would write something like this, pi 2x squared. That's wrong. When you substitute, it needs to be in brackets because the actual number in front of the x is also squared. It's not just the letter. So keep that in mind. I've seen that mistake even in top sets. Happens all the time. Times 9x equals 4 over 3 pi r cubed. I'm going to cancel the 4 out from both sides now to make my life easier. And that gives me 9x cubed equals a third. Sorry, there shouldn't be a pi there actually. R cubed. Times both sides by 3, we get 27x cubed equals r cubed. And because I want r equals an expression for r in terms of x, I'm going to now cube root both sides. And when I cube root both sides, 27, the cube root of 27 is 3. Cube root of x cubed is x. The cube root of r cubed is r. So r is simply 3x, 3 times x. So again, it's a bit of a beefier question, so let's have a look at where you would get the marks. So you get a mark for setting up an initial equation, a mark for actually doing the substitution, so that would be a mark over here, and then a mark for getting the final correct answer. But yes, r equals 3x in that question. Very interesting looking question. So we have a square where D and P are going to be y-intercepts, A is an x-intercept, okay. PAB is a straight line, cool. The equation of the line that passes through points A and D is this. So AD, so that's y equals minus 2x plus 5. Find the length PD. So PD, when I think of the length here, all it's going to be is, well, if you think about it, these are y-intercepts. So let's say P is minus 4 and D is 5. The total length is just going to be 9, right? The difference between 5 and minus 4. So all I need, what I'm thinking for the end goal of this question, is I want to know the coordinate of D, so the y-intercept D, and the y-intercept P. Now, the y-intercept at D we actually already know. Because look, this line here has equation minus 2x plus 5. If you remember, the equation of a line is mx plus c. C is your y-intercept. So D is actually at 0.5. Another way to look at it is at the y-intercept, x equals 0. If I sub in x equals 0 into this equation, I get y is equal to minus 2 times 0, 0, plus 5, which is 5. Wonderful. I'm almost there. So, how are we going to work out point P? Well, I could do something very similar to how I worked out point D, which is if I knew the equation of a line going through PAB, I could then just look at the y-intercept and there you go, I'm done. And that's exactly what we're going to do. So remember, in questions, they have to give you enough information to actually answer the question, obviously, but they never give you excess information. At the moment, it says point A is on the x-axis. I'm going to be using that somehow. It's also told me this is a square. I'm going to use that somehow as well. They've also given me this right angle. I'm going to be using that. Everything. And here's the trick. The line DA and PAB are perpendicular, which means the gradient of PAB is the negative reciprocal of the gradient of DA. So if this gradient's minus 2, all we do is we change the sign, so now it's positive, and we do 1 over it. That's my gradient of a line. Now, what two things do you need to work out the equation of a straight line? Well, you need the gradient and you need a coordinate. Now if I look at PAB, I obviously don't know P because that's the coordinate I want in the end. I don't know B and I can't really work it out, but A I could work out because it's the x-intercept of this line here. Now how do you work out x-intercepts? X-intercepts are when y equals 0. So if I go here and I sub in y equals 0, we get 0 equals minus 2x plus 5. Add 2x to both sides, 2x equals 5. So x is equal to 5 over 2 or 2.5. I'm going to leave it as a fraction because on a non-calculator paper I find it easier to deal with fractions than decimals. There you go. So now our y equals mx plus c is y is equal to a half x plus c. Sub in that x equals 5 over 2 when y equals 0. So 0 equals a half 5 over 2 plus c. So that would be 0 equals 5 over 4, let's write it as, plus c, which means c is equal to minus 5 over 4. That is my y-intercept. In other words, that's this coordinate here. So the length from P to D is just the difference between 5 and minus 5 over 4. So 5 minus 5 over 4 becomes 5 plus 5 over 4. To do this, we're going to have to make them both fractions. Times top and bottom by 4. I get 20 over 4 plus 5 over 4, which is 25 over 4. And that is your final answer. That's a 4-mark question. It's pretty intense, not going to lie. In terms of where you'd get your marks from, you'd get a mark for working out the 2 coordinates here, because you need them for the question. A mark for getting a correct equation of a line for PAB, and of course a mark for getting the right answer. Kind of obvious, really. So this looks like a sketching question. Actually, no, not sketching, sorry. It's an actual drawing question of x squared plus y squared equals 4. Now, x squared plus y squared equals any number is actually a circle. So the radius of the circle I'm about to draw is 2. So how would I do this in the exam? Now, how I'll do it in the exam is not how I'm going to show you right now. How do you draw circles in maths? Using a compass. So what you're going to do is you're going to get your compass, which looks like that, right? You're going to make the width of the compass 2 centimeters or 2 units. So what I would do is I put the sharp bit on the origin, put the leg on 2, and you're just going to draw a circle. That's it, for 2 marks. Why did you get 2 marks? Because you get a mark for the correct radius, and the second mark for actually drawing a circle with the compass. So again, you get the sharp bit of the compass, put it on O, stretch out the pencil till 2, and just draw a circle. So you're going to get something that looks vaguely, and I promise, give me some slack in this. But if I was doing this, I would, actually it's not bad. I mean, obviously I have autocorrect, but something vaguely similar to this. But it needs to be perfect. It needs to be done with a compass. It has to be. 2 marks on the line, okay? This one, the drawing of circle graphs, is not often taught at all in school. But I've seen it come up a couple of times in recent years. So please, please make sure you do it. For part B, sketch the graph of cos x. Honestly, this is mainly just memory. So sine and cos look very similar, except one starts at 1, the other one starts at 0. So sine starts from 0, and every 90 degrees it changes. So it goes from 0 to 1, or 1 to 0, or 0 to minus 1, etc. Cos x starts from 1, and again every 90 degrees it changes. So, oh god, that looks kind of terrible, but... And it says only go up to 360 degrees, so just like that. That's literally it, all there is to it, really. You could keep going, but it does say from 0 to 360, so I stopped at 360, just FYI. This is extremely similar to the question with the cylinder and the sphere, but instead it's a cylinder and a cone that they've made the same. But again, you're going to get h in terms of x. So it's literally the same as question 2. Yeah. Cylinder and a sphere, same process, rearranging for r. In this case, we're rearranging for h. That's it. Now, you are given the formula for the volume of a cone, and normally they even put it in the question. But in this case, the volume of the cylinder and the cone are equal. So for the cylinder, pi r squared times h. I say times h, I mean times the height of this. And for a cone, it's a third pi r squared, but it's times the, what do I want to call it? Times h as well. So, just like that. Anyways, going through this, let's sub in our values. We have pi. R squared is just x in this case, so we can write x squared. But remember, if it was 2x, I'd have to put it in brackets. Times, funnily enough, 2x. And that equals a third pi, what's the radius, x squared again, times the height, which was the height, h. And it looks like we can cross out a bunch of stuff. Interesting, we can cross out quite a bit. So, I'm going to cross out the pi's first, because that makes the most amount of sense to me. I can cross out the x squareds on both sides. So I get 2x equals 1 over 3l. Why did I write l and not h? That should be h, sorry. I think I meant to write h, but my hand didn't move enough. A third h, which means times both sides by 3, h is equal to 6x. Classic. So, again, a mark for making them equal, a mark for a substitution, a mark for, oh my god, 6x equals 6x? Come on, Mitchell, what are you doing? Equals h. Sorry, I need to slow down a bit, but that's where you get your 3 marks from. Okay, so with this question, I've seen this formula so many times. I've used it a couple times, but a substitution in there is actually a bit different. So, how would I do this? Well, if I'm looking at this, mixed numbers in a non-calculated paper make me feel sick. So what I'm going to do is I'm immediately going to change these into improper fractions. So you do 2 times 2 is 4 plus 1 is 5, so that's 5 over 2. And v is equal to 3 times 3 is 9 plus 1 is 10 over 3. And now I'm going to sub in. It says find the value of f. Sure thing, boss man. Let's do it. So 1 over u. Now, if I say 1 over u like this, there are a few things that you can do to help yourself out. One of them, and again, this is aimed for a grade 9 student, so hopefully this makes sense, is doing 1 over a fraction is the same as taking the reciprocal. So, that would just give me 2/5 plus 3/10. Now, if you're not happy with that, I understand. 1 over 5 over 2 is the same as 1 divided by 5 over 2, right? Keep, flip, change. So we're going to have 1 over 1 times 2 over 5, which equals 2 over 5. That's where the derivation comes from. So no matter if you want to do 1 over being the reciprocal, which it is, or you do it kind of more manually where you divide, you get the same answer. It doesn't make a difference. Adding those two together, well, we'd have to times top and bottom by 2, which gives me 4 over 10 plus 3 over 10, which is 7 over 10. But that equals 1 over f. Now, again, you could just take the reciprocal and say that f is equal to 10 over 7. But if you're not happy with that, here's what I would do. Times both sides by f to bring it up to the top. We get 7 over 10f equals 1. I'm going to times both sides by 10. 7f equals 10. Divide both sides by 7. You get f is equal to 10 over 7. No matter which way around you want to do it, you'll get the right answer regardless. In terms of your marks, you get a mark for changing into improper fractions. You get a mark for the substitution. And a final mark for getting an answer of f equals 10 over 7. Not too shabby. Now, rearrange this to make you the subject of the formula. So, how would I do this? Well, actually I'm going to rewrite this again because it is kind of cramped up there with all the other random stuff that I've written. Now, it is tempting to just times through by u and v or something like that, but that will make this a bit of a mess. So instead what I'm going to do is I'm going to treat this as if I'm adding fractions. So if you try and add these two, you're going to have a bit of a bad time because you're going to have multiple u's. So instead I'm going to move the v over, so I get 1 over u equals 1 over f minus 1 over v. I'm going to do the subtraction now. So I need to times the first fraction by v top and bottom, so v over fv, and the second fraction by f over fv. Combine these two together, you get 1 over u equals v minus f over fv. But wait, there's more. Remember what I said back here when I got to this answer? I could just take the reciprocal in order to get the answer 10 over 7. I can do the same thing here. If I just flip both sides, take the reciprocal of both sides, I've gotten my final answer. But what if you don't like that? No worries. If in this alternate parallel universe where you didn't know to do that, times both sides by u, you get 1 equals v minus f over fv times u, times both sides by fv. Fv equals, is that a u? No, it's a v. V minus f times u, divide both sides by v minus f. So either way you do it, it's totally fine. You get the right answer anyway. The marks here are a lot more savage. Basically, you get a mark for combining the fractions and a mark for taking the reciprocal. So doing this method will cost you some time, but it is still correct. Do not worry. And yet more geometry questions. I should actually probably tell you now. Now we're on our third geometry question in 7 questions. The reason why they put so many into this is because for the last couple of years, geometry has been the worst answered topic. And from the students that I have in tuition and in school, geometry tends to be the thing that people hate the most. Which is good, because it was algebra before, and algebra is probably more fundamental than geometry. But geometry is kind of bad. That's why it's in this grade 9 paper. Now, if we read through this, so solid cone, solid hemisphere, it's not going to be volume, I think. The surface area of the cone is equal to the surface area of a hemisphere. Okie doke. Now, they give you these equations. They do not give you the surface area of a cone. They give you the surface area of the curved part of a cone, which is pi r l, where L is actually the slanted side. In terms of a sphere, they give you the surface area of a sphere, not a hemisphere, which is 4 pi r squared. Now here's where we need to be careful. Neither of these are the complete story for these shapes. Let me tell you why. The surface area of the cone means we're going to have obviously the curved part, pi r l, wonderful, beautiful, cool. But there is a bottom part to the cone, right? Which is this bottom circle. So we need to add a pi r squared. The pi r l is just the curved part. I want to say triangular, but I know some people might get angry at me. But the pyramid part of the cone. Okay? The circle at the bottom counts for the surface area. If you imagine having a cone back in primary school, when you turned it over, there was a solid surface there. It's not like an ice cream cone, which would be hollow. It would have that cap. But what about with the sphere? Surely not. Well, there's two things with the surface area of the sphere. One, because it's a hemisphere, it's going to be half of this, so 2 pi r squared. But again, there is a bottom circle, so plus pi r squared again. And those two will be equal. So many people get that wrong. So many people. They either, especially with the sphere, they just half the surface area of a sphere, and they go, there you go. But think about it. If I cut like an orange in half, I expose a new surface, right? So it means its surface area actually increases. So you're not just dividing the surface area in two, you also expose a new area, which has to be taken into account. Think about cutting a sphere in half. You would also get a new face that is exposed. So, the other problem I notice is we don't have L. But with a cone, H and X are in right angles. So using Pythagoras, we can say that L squared equals H squared plus X squared. Why? Because Pythagoras' theorem says that A squared plus B squared is C squared. A and B are the short sides, and L is the hypotenuse. So L, in other words, is going to be the square root of H squared plus X squared. Okie dokie. Find an expression for H in terms of X. Good lord, this is going to be fun, isn't it? So pi, what was the radius? The radius was X. In fact, I'm not going to put a bracket. I'm going to be bold. Times square root H squared plus, okay. Alright. H squared plus X squared? Yeah, X squared. Plus pi r squared, so that's pi x squared, equals 2 pi r squared, so 2 pi x squared, plus pi x squared. And the first thing I notice is I can get rid of pi x squared from both sides by just doing minus pi x squared. Both sides. I can also divide through by pi and by x. So I'm left with, okay, this isn't so bad. H squared plus x squared equals 2x. I'm now going to square both sides to get rid of the square root. So h squared plus x squared. And don't forget again, I've squared both sides. So that is not going to be 2x squared, it's going to be 4x squared. Minus x squared from both sides, you get h squared equals 3x squared. Then just take a square root. Yeah, square root both sides, you get h is equal to the square root of 3x. Boom. 4 marks, okay. So in terms of where you get your marks from, as usual, again, you are given these two surface areas, but you're not given the full thing. So obviously you get a mark for the answer, you get a mark for your substitution, you get a mark for the correct expressions on both sides. Fun. Look at that, it's everyone's favourite question. Using process of elimination, you need to match up the graphs to the equations. I'm going to zoom out a bit. This might be a bit harder for you to see now, but I would probably target the ones I'm most confident in. So for example, I'm hoping everyone here is really confident with quadratics. So which one's going to look like a U shape? Well, I already see E, but is there any others that I use? No. So I'm going to eliminate E and I'm going to put that right here. Now, how does this question work? Now, with the marking, I can't tell you the mark scheme. I can't tell you where you gain your marks because you start off with 3 marks. And every mistake costs you a mark. Pretty brutal. Now, what about x cubed? Some people hate the x cubed graph. I don't mind it. But it's the one that is like the normal x cubed graph looks like that. So it kind of looks like D. So I'm going to put D there. If any of them that you're unsure of, leave them for last. Why not, right? Okay. Now this one here looks really similar to the 1 over x graph. Now they've said that it's 4 over x, but that's the same thing. I've just realised there's 4 in literally all of these. I don't know what's going on there, but whatever. Now, these two, B and F, look very similar, but remember what I said. The sine graph starts at 0, the cos graph starts at 1, but other than that, they're practically the same graph. So B is cos and F is sine. So B is cos, I said, and F is sine, which means the last one left. This weird looking one is just C. So again, save the ones that you are stuck on for last. Oh look, more geometry. How original, right? But is a bit more nice because it's not actually a geometry question in this first part, because it gives us the equation for the perimeter and it just says rearrange to make x the subject, which it's not the easiest thing to do in the world, to be honest. It's not great. So how would I do this to make my life as easy as humanly possible? Well, I'm noticing obviously there's 2 x's, kind of sucks. I would probably times everything by 2 to get rid of the fraction. So if I times everything by 2, I get 2p 6x plus pi x. Okay? And that's pretty good so far. And the next thing I would probably do is, well, if I just factorize out the x, I'm actually done, basically. So I get 6 plus p, pi even. X, divide both sides by 6 plus pi, we get 2p over 6 plus pi gives me x. Perfect. Only 2 marks. Yeah, fantastic. All right. However, the area is given by a is equal to kx squared. Find the exact value of k. So basically, we just need to find the area of this shape. And if I look at it, if I draw a line going from A to D, this is a semicircle plus a rectangle, I want to say. Yeah, semicircle plus a rectangle. Never mind, I'm an idiot. It's a square, not a rectangle. Which makes my life easier. So this is also x centimeters. And it means that the diameter of this is x. So the radius would be a half x. Cool, yeah, so it's just the area of a square plus the area of a semicircle. So area of a square would be x squared. Yep, because x times x. Pi r squared for the area of a circle, but then we're going to divide it by 2. So pi, a half x squared. Remember, you always, 1000% of the time, you always want to put the you want to put it in brackets to make sure you remember to actually square it. We get x squared plus you know what, let's take our time with this. 1 over 4x squared all over 2. So if I expand that out, we get a quarter divided by 2 is an eighth pi x squared. So we want to find the exact value of k, so all they've done is factorized out x squared. So we'll have 1 plus 1 over 8 pi, if you look, because 1 times x squared will give me x squared. 1 over 8 pi times x squared will give me 1 over 8 pi times x squared. So that's all they've done, and this thing here is our value for k. Perfect, not too bad. Express the recurring decimal as a fraction. Okay, the goal here is essentially to get this same recurring decimal, as in the same recurring parts in the same place, with either 10x, 100x, 1000x, a million x, whatever the hell you want to use. So for some people, I like to just times it by 10, and that'll be 1313. So that isn't quite the same, because if you line up the decimal points, in fact, let me line it up. Actually, no, that's lined up properly. We have 1 and 3, 3 and 1. So if I subtract them, I won't get the right answer. But if I do 100x, look what I get. I get 21 point, and then I'll get 1. God damn it. 3131 is what I was meant to write. Ugh. It's because I was looking at the second line, not the first line. 3131, like so. And if you notice, the second decimal place is 1, the third will be 3, and that will repeat forever. So the recurring decimals now are here and here, and in the first one they're also in the same position, so I can do it. Another way I like to explain it is, depending on how many recurring decimals you have, so in this case we have 2, that's what you're going to times by. So I'm going to times by 100 because it has 2 zeros, because there's 2 recurring decimals. If there's 1 recurring decimal, you would times by 10 because there's 1 0. If there's 3 recurring decimals, you would times by 1000, and so on. Then all you're going to do is do 100x minus x. And I like to write them on top of each other because I'm extraordinarily paranoid. And that will be 0 point and then 2, 1, 3, 1, 3, dot, dot, dot. And obviously the 1, 3s are cancelling, going on forever to infinity. So that would just give me 21.1. Yep, cool. So that's 99x equals 21.1. So x is equal to 21.1 over 99. And that's 2 of the 3 marks. Why? Because you cannot have decimals in a fraction. So we're going to times 10 times 10, and we get 211 over 990. That's our final answer. Again, get rid of the decimals. This might be the strangest question I've ever seen, because I can prove this in one step. They're proving congruency. The way you prove congruency is either you have 3 sides, you have 2 sides and the angle between. So side, side, side is of course if you have all 3 sides, duh. Side, angle, side would be if you have 2 sides and the angle between them the same. Angle, side, angle is when you have 1 side and the angles that are like touching it, so to speak, or 2 angles on the side between them. Then you have RHS. Now, I'm pretty sure this isn't right angle, but I can't tell, so I'm not going to use this one. But if I look at this, AB equals BC equals CD equals DA. So in other words, all those 2 sides are already the same, and they share the side BD. That's it. Because they share BD, and they already tell me in the question AB equals BC equals CD equals DA. Okay, sure, I guess. Algebraic proofs, another topic that is normally, well, historically, not answered very well. Prove using algebra that the sum of 2 consecutive whole numbers, or they may say the word integer, is always an odd number. Now, it's interesting because they introduced the word consecutive last year or the year before, I can't quite remember, and very, 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 very few students got it right. It just threw everyone off. Well, let's think about why. What does consecutive mean? Consecutive means the numbers are next to each other. They come one after another. Right? If I say I was late 3 consecutive days, it means I was late on 3 days that are next to each other. Monday, Tuesday, Wednesday, for example. So how would I describe this algebraically? Well, if you think of just a number, you would give it the letter n, or x, or y, or whatever. What would the number next to it be called? Well, it would be called n plus 1. Right? Now, could you use n minus 1? Yes, you could. Because that would also give you a consecutive number, right? so 3, 2, 1 is consecutive as well as 1, 2, 3. But I'm going to use n plus 1. Getting that step gets you a mark, and basically no one managed to get that when it wasn't this exact question, but it was a question that had the word consecutive in it. Barely anyone got it right because they couldn't get the first step. So, that the sum is always odd. So what does sum mean? Sum means add. So I'm now going to simplify that and I get 2n plus 1. Second mark. Now, prove it's always odd. Well, 2n plus 1 is always odd because 2n is always even, right? If I times an integer by 2, it has to give me an even number. So 2n plus 1 is always going to be odd. Why? Because what happens when you add 1 to any even number? You get an odd number. So because 2n, 2 times a whole number, is always even, when I add 1, I always get an odd number. Okay, a sampling question, again quite rare and interesting to have on a non-calculator paper, but be that as it may. These are 1,000 teenagers and their information about their ages apparently. Sophie takes a sample of 50, stratified by age. Calculate the number of 14-year-olds you should have in a sample for 2 marks. So stratified sampling, essentially it means that, let's say half of the teenagers are 13 years old, then that means half of our sample should be 13-year-olds. A quarter of them are 16-year-olds, then we take a quarter of 50, and that's how many 16-year-olds we need. So we need to work that out, but for 14-year-olds. So there are 180 14-year-olds out of 1,000 total people. That is the fraction of people that are 14 years old in this sample. Sorry, not in the sample, in this group of teenagers. Then we're just taking that fraction of 50. So we could, I guess, like simplify it a little bit, like cancel out a 0. We can make that 9 out of 50. Any simpler than that? Let's say 9 out of 50. Then we're taking 9/50ths of 50. And if you notice, obviously you divide by the denominator. 50 divided by 50 is 1, times 9 is 9. That's how you do stratified sampling. But yeah, kind of interesting, I suppose. The classic proportion questions. I love these. P is inversely proportional to V. You get a mark just for writing this. 1 mark. The second mark is for actually subbing in these values to work out K. So when V equals 8, P equals 5. So 5 equals K over 8, which means K is equal to 5 times 8, which is 40. Second mark. I love it. How easy is this? The last mark is simple. It's just for writing the formula. P equals 40 over V. Beautiful. Now, sometimes I will say they're giving you an extra mark here. Normally, there's only one part, which is when V equals 8, P equals 5, calculate the value, in which case you get the third mark for doing the calculation. But in this case, you get a free mark. Why not? Calculate the value of P when V equals 2. So P equals 40 over 2. Then use your massive, colossal brain to work out the fact that it would be 20. That's it. Nice and easy. There are actually quite a few different ways to do this question. So the diagram shows a regular hexagon and a square. Calculate the size of angle A. And as you can see, angle A is this exterior angle here. And one thing you could do is, sure, we're just going to work out the exterior angle of a hexagon and the exterior angle of a square and add them together. That's one thing you can do. Or you could work out the interior angles add them together and minus them from 360. I would say exterior is easier just because you just do 360 over n for exterior, whereas with interior you have to do n minus 2 times 180, then divide by the number of sides you have. So, with a square, I mean it's probably fairly obvious it would be 90 degrees, right? 360 divided by 4 is 90. But with a hexagon, we're going to have 360 over 60, cancel out the O's, the zeros, and you get 6. That's not right. What have I done? Oh, I've divided by 60, not... I jumped ahead in my working out. My apologies, I jumped ahead in my working out. It would be 60 degrees. So that means the size of angle A is just the sum of the two exterior angles we just worked out, which is 150 degrees. For 4 marks, that is really impressive. And we have taken quite a big shortcut. If you do the interior angles, it will take you quite a bit longer because you'd have to do the divisions and stuff like that. I love this question. This question is actually really, really good. Show that, or find the size of angle X. And, I mean, if you look at this, we have parallel lines, so I might be thinking of Z, F, and C angles, right? So if I try and apply that now, the Z angle here would mean that this angle is 38 degrees. Now, remember, when it says show you're working out, you would have to say ABD equals 38 because alternate angles are equal, right? You have to use that language. Now, because this DAB is a isosceles triangle, that means the base angles are the same, which means that's also 38 degrees. And again, I'm using that language. DAB equals 38 because base angles in an isosceles triangle are the same. If you look at this bottom triangle, it's actually identical. Like, it's literally the same thing again. So if you want to, you could just write triangle CDB is congruent to this top triangle, so the angles are the same. I can work out this angle now by doing 38 plus 38, which is 96, and then minusing that from 180, which would be 84. Yeah, 84. Which means this side is also 84. Which means X is just 360 minus 84 minus 84. Which is, so 84 plus 84 is 168. Yes, 168. So that'd be 102. 102. Cool, that should be it. That should be 76. Sorry, hang on one sec. 76. 104. 4. So it's 360 minus 208, which gives me 152 degrees. There we go. Not too bad. Not too bad in terms of working out. 3 marks, again, you just have to give your wordings. Your wordings, your reasons. I would argue this is the first truly difficult question. It's 5 marks. And just looking at it, it tells me all stuff about right angle triangles and all this crazy stuff. So in this question, this is actually very similar to A-level maths questions, by the way, year 12 maths. So I would always recommend drawing out a diagram. And A is on the left side of the y-axis. So A is minus 2, 1. B is kind of along here, 6, 5. And C is, it's between A and B, and I'm just going to put it up here. So how do I know it's up here? Well, to be honest, it's either going to be up here or it's going to be down here somewhere, right? That's the only 2 places it could be. I'm going to move it over slightly. And it tells me it's the vertices of a right angle triangle. So let's complete this triangle just to make it. Ooh, I have not drawn this too great. Okay. I have not drawn this too well. Alright, let me just get rid of these 2 sides. I'm going to tuck this in a bit. So, the reason why I know, I'm going to explain in a second why I know where the right angle is, I promise, okay? I'm not making this up, I promise. This should be the right angle. Why? Because it says that the triangle is ABC, so the middle angle, the middle letter is the one that's right angled, right? So ABC, B is the one with the right angle. That's what's meant to be. But for some reason, I can't draw a right angled triangle today. Okay, I've done something quite smart. Move that over. There you go. So, we need to find an equation of the line that passes through AC. Now, the fact that it's a right angled triangle does matter, because that means that the gradient of AB is perpendicular to CB. So AB and CB are perpendicular. So let's write out the two gradients. Not in black, let's do it in blue. MCB, should I call it CB or BC? I'm going to use BC. Is difference in y over difference in x. So it's going to be k minus 5 over... I had it right the first time. I should have used the other one. You know what? Screw it. It's fine. 4 minus 6. So it's k minus 5. It doesn't matter which way around you do it. I just wanted to avoid the negative, and I messed it up a little bit, but that's fine. And MAB are going to be negative reciprocals of each other. So we're going to have 5 minus 1 over 6 minus minus 2. So, 4 over 8, which is just a half. Interesting. So, this right here is the negative reciprocal of this. So, I mean, there's a few different ways that you can put this, but if I flip this and make it negative, it should equal 1 over 2, essentially. So, take the negative reciprocal of this and I get minus 2. So, minus 2 is equal to k minus 5 over minus 2. Times both sides by minus 2, I get 4 equals k minus 5. Which means k is equal to 9. That's how I do it. So again, the way I worked that out is I took the negative reciprocal, it doesn't matter of which one you take the negative reciprocal, and made it equal. The reason for that is perpendicular gradients are negative reciprocals of each other. So why is that important? Well, if I want the equation of the line passing through AC, I need the gradient of AC, and to do that I need the coordinate of C. So now MAC is going to be the difference in y over difference in x again, so 9 minus 1 over 4 minus minus 2. So that is 8 over 6, which is 4 over 3. Subbing it into y equals mx plus c, we get y equals 4 over 3 x plus c. We can use a coordinate. I'm going to use the c coordinate. So c is 4 and 9. So I'm going to sub in x equals 4 and y equals 9. I said x equals 4, good. Over 3 plus c minus it over. We get 9 minus 16 over 3 equals c. So that would be 9 over 1 minus 16 over 3. Times them by top and bottom by 3. We get 27 over 3 minus 16 over 3, which is 11 over 3. So our final equation is 4 over 3x plus 11 over 3. But if you notice, our answer has to be in the form ay plus bx equals c, where a, b, and c are integers. If I times everything by 3, everything's now an integer. 3y equals 4x plus 11. Then I'm just moving the x over to the left side. We get 3y minus 4x equals 11, because that's the form it told me to put it in. That's the only reason why I've done that. And we are finished. For here, we have a speed time graph for a car journey that took 100 seconds, and it says the car travelled 1.75 kilometers or 1,750 meters in the 100 seconds. Work out the value of v. Now, a speed time graph, where do you get distance from? Why do I know I'm using distance? Because they gave me the information. I have to use it. And it's also the only information that will help me work out v. So, how do you get distance from a velocity time graph? You work out the area underneath. Now, some people would change this into a triangle, a rectangle, and a triangle. You'll get the right answer, but I'm not going to do that. Why? Because when you have 3 different shapes, you are more likely to make mistakes. This shape here is a trapezium, and the area of a trapezium is a half a plus b times h, where h is your vertical height, so in this case v, and a and b are the two opposite parallel sides. So that means it would be a half. A is going to be this middle section, which is the difference between 60 and 20, so 40 seconds, plus the total length, 100, times by v should equal 1,750. So why have I changed it into meters? Because my speed is in meters per second, not kilometers per second. So that means I need to change my distance into meters. So I'm going to times both sides by 2. No, I'm not going to actually, because I've spotted something. A half, 140 v equals 1750. So that means 70 v equals 1750. Divide both sides by 10. Okay. 7 goes into 175. So 20 times make it to 140, plus 35, so plus 7 more times, so it's 25. Or you can use good old-fashioned bus stop method. But yeah, 25 meters per second. Describe the acceleration of the car for each part of the journey. When they talk about parts, they're talking about every time the acceleration changes. So why have I highlighted those 3 areas? The acceleration equals gradient, equals the gradient of the line. So those 3 times is where where the gradient changes, so therefore the acceleration changes. So from 0 to 20 seconds, we have constant acceleration, right? Because it's a straight line going upwards, there's a positive gradient. This flat part from 20 to 60 is no acceleration. Why? Because there's no gradient. And then from 60 to 100 is a constant deceleration. There you have it. Not bad. So we have a solid, has a uniform cross-section, where the cross-section is a big old rectangle and is semicircle joined together, and they want an expression for the total volume. So what we're going to do is I'm going to split it into 2 shapes. Shape 1 is a semicircular prism, and remember, how do you work out the volume of any prism? You work out its area and you times it by its length. So in this case, what would the area be of a semicircle? Well, it would be pi r squared divided by 2. So it's going to be pi, the radius is, and this for, object 1, the radius is going to be x over 2, r squared, and then also divided by 2. And then we're going to times it by its length, which is x. So again, the semicircle is pi r squared divided by 2, but the radius is x over 2 as well. Object number 2 is just a classic cuboid. So the rectangular face is going to be x times 2x, and its length is going to be x. So it's just going to be x times 2x, which is of course just 2x cubed. This heinous looking thing is going to be, how do I want to do this nicely? Okay, simplifying this is slightly annoying, but that's fine. Pi x squared over 4 divided by 2 times x. So that would be pi x cubed over 8. And we're going to add, so for the total volume now, we're just going to do pi x cubed. Actually, should we call it pi over? Okay, pi x cubed over 8. In fact, I'm going to write that second for a very good reason. Because if you notice, this kind of looks like this. And then we're going to have 2x cubed. So our answer is 2x cubed plus, I'm bringing the 1 over 8 forward, pi x cubed. So here we have our value of a is 2 and our value of b is an 1/8. And hopefully that makes sense. It's 4 marks. It's not too bad. Again, a boatload of geometry in this wonderful paper that we're doing. Last question is functions, funnily enough, and we have just 3 marks here, and it says f of x equals 2x plus c, g of x is cx plus 5, f g x is this, work out the value of d. So f gx, what does that mean? Well, this is what I like to do with some of my students, is you're subbing g of x into f of x. So I like to write f of x, but where I see an x, I'm going to put a big set of empty brackets, plus c. And now I'm going to put g of x into those brackets. So cx plus 5, which equals 2cx plus 10 plus c, which is, we can't simplify that at all, but it tells me that it's equal to 6x plus d. So these two things must be equal to each other. So how on earth are we going to work out the value of d? Well, this is where things get a bit more interesting. If I have a look at this expression here, this equation, then when I simplify this side, I should get the other side. So in other words, everything in front of x here is the same as everything in front of x here. So 2c equals 6. So c is equal to 3. Because again, everything in front of x here is the same as everything in front of x over here. Now, using that logic, that means 10 plus c should also equal d. But I know what c is. It's 3. So 10 plus 3 equals d. 13 equals d. The reason why I need to do that is, again, I'm just using the information they give me. I know students who would look at this and they'll go, oh, I don't know what to do. Well, it says here fg of x. Why don't you find an equation for fg of x and see what happens? After that, it's not too bad. But that does bring us to the end of the paper. Again, if you managed to watch the whole thing, well done. If you didn't watch the whole thing, you're stealing my watch time and I hate you. Just kidding. But again, I have 9 other papers linked in the description in the same kind of style as this one. I'm not going to lie, I think the other ones are actually better. I don't think this was the best paper they've released. The previous ones were better. But I also have gold papers linked in the description, which are also grade 9 style questions if you want that. So tons and tons of practice for you. I will link the paper in the description. And again, all the other papers that I've done, full YouTube walkthroughs, have all of the, they also have the papers with them as well. So we've got all of that to look forward to. If you would like to join the Discord, then of course the link will be in the description. I may do a last minute revision live stream on Wednesday, just FYI, but I'm going to announce that in the Discord. But that's also the best way you can communicate with me and I can respond. But you also have other really smart people, even people in A levels already, who can come back and kind of help you with some GCSE maths if needed. But other than that, best of luck with the exams you have before Thursday, and I'll see you in the next one.